are trying to consolidate the background required for complete understanding of the module number 5, that is network functions. Even though we had referred the things before, we took this opportunity to revisit the things and to consolidate our background and understanding. So, we are now aware that we are having a circuit which consists of R, L and C and dependent sources. That circuit can be looked either from one port or from two ports together. If we look from one port, then the two parameters are either impedance or admittance. Impedance or admittance means if I look towards a circuit which consists of R, L, C and dependent sources, then I can see it to be an impedance. Means again, when I repeat, even though the ratio it is defined as Laplace transform of voltage upon Laplace transform of current, I try to simplify it in a sense that the concept of ratio can be defined if and only if the input source is of the type or the nature of the signal is such that its differentiation and integration does not make a significant or does not make a change in the fundamental characteristic. So, when we look at the functions of one port, we take the ratio of voltage upon current there. We take the ratio of voltage upon current there, but for considering this is analysis. Analysis is providing us some additional information about the circuit. And for this analysis, we are presuming that I am applying an input of the type e raised to st to the circuit. So, if the input is of the type e raised to st to the circuit, in that case, voltages between any two points, what is it? I had already told few lectures back also. Merely by listening every word from me with complete attention, that is a necessary condition for understanding of this module, but not sufficient at all. I again repeat, listening continuously with full attention is a necessary condition for understanding. I have never claimed that this is a sufficient condition. Despite fully listening to the lecture with full attention, it is likely that you may not understand. But being a necessary condition, without listening with attention, you will never understand. There is, I can say with complete level of confidence, that no alternative remedy exists for you, at least for this module of this subject, wherein you can get some external aid to understand these themes, so that you may afford not to listen here. I am fully aware that alternative avenues are available for various subjects. I am also aware that alternative avenues are available for this subject also, because in the university pattern its name is electric circuit analysis. So the avenues may not have printed circuit theory because this was just revised this time. But still I can say that for module 1, for module 2 even to some extent, module 3 and 4, I don't know whether you have exercised or otherwise about those avenues. But for this particular module and this type of nature of discussion, no alternative avenue is available. Therefore, there is TINA factor, there is no alternative. So because of TINA factor, at least you try to listen every word. Just turning the pages to kill time, having eyes looking at the fan. So please do not resort to such means. Availability of video is for the benefit of those who might have missed the lecture, or despite their full attempt to understand, they might not have understood. So this is supplementing the live classroom and not substitute for the same. Therefore, you should not take recourse that I am not in a mood now and I will watch the video later. So that should not be our consideration. So from that point of view, we get a concept of ratio of voltage and current. So voltage upon current is impedance and current upon voltage is admittance. So as regards to network functions for one port network, these are impedance and admittance, transform impedance and transform admittance. Now when we look at two-port network, in that case what happens is we get two voltages and two currents. And we can get four transfer functions. Please keep it in mind that it is different chapter than two-port network parameters. So first is voltage transfer ratio. When we have a two-port network and 4 points, 1 dash, 2 dash, if something needs to be connected to this, otherwise it does not have inbuilt independent sources. If nothing is connected to it, it will be in zero state. It may contain dependent sources, but dependent sources, and again the nature of dependent sources is linear dependent sources. We do not, as regards to dependability, I don't know, you should have questioned whether I can have some dependent source like this. This is a dependent current source and it is equal to 0.3 upon I2, where I2 is current in some other R. It is not like this at all. The dependent sources, whatever we have learned, are proportional directly to either voltage or current. A voltage dependent voltage source generates the voltage which is proportional to voltage at some other place. Voltage dependent current source which generates the current which is proportional to voltage at some other place, and current dependent current source and current dependent voltage source. Right? So all four combinations we are having. In all these combinations there is direct proportionality. That is very much important. So because of this, when nothing is connected, no current can flow anywhere. There cannot be any voltage between any 2 points in the circuit. Right? So the inside block, this is the two-port network, may contain R, L, C and dependent sources, right? So with this now, then how can you take the ratio? It is port 1, so V1, V2, I1 and I2. V1, V2 and I1, I2. So voltage transfer ratio. How can we take voltage transfer ratio? Voltage transfer ratio corresponds to V2 upon V1. V2 upon V1. So V1, V2, I1, I2. So how many ratios you can take? You can take 8, but of them 4 would be just inverses of 4. So we decide to have 2 in the numerator and 1 in the denominator. We decide to have 2 in the numerator and 1 in the denominator. So what we get? V2 upon V1, that is Z21. V2 upon V1. How exactly, what is to be done here, whether something is also connected here, all those issues we will discuss. Then Y21 is, sorry, it is V2 upon I1, I2 upon V1. Then we have got G21S, or G21, it is voltage gain, V2 upon V1. And there is another one called as current transfer ratio, where alpha is I2 upon I1. Alpha is I2 upon I1. I am specifically avoiding writing S here into bracket. That one we will put because we are not yet going for Laplace transform. I am trying to explain it in as simple manner as we can. So rather than giving theory, we take one example for which we calculate all parameters. Find out the following parameters: G21, Z21, these are the transfer functions, and driving impedance Z11, and driving impedance Z11. So I want everybody to find out all these three answers. You can put a pause. So I hope that you now have got enough competency at least to compute the network function. Ability to compute network function is again, as I stated, necessary condition to understand network function and not sufficient at all. So network function ultimately comes out to be, it may be a driving point function or a transfer function. It ultimately comes out to be a ratio of a polynomial in S in the numerator and another polynomial in S in the denominator. The network function works out to be a ratio of two polynomials, a numerator polynomial and a denominator polynomial. Then, depending upon the nature of the polynomials, what kind of function it is gets decided. As regards to passive networks, there is no much scope, but for active networks, it is likely that the network may be unstable network. We shall discuss all these factors. We will take suitable examples and we shall prove exactly what we mean by instability, what we mean by stability of the network, stability analysis of the network function. Now, I have here what has been asked, G21, Z21 have been asked, but alpha 21 and Y21 are not asked. What is the reason? Alpha 21 and I21 are not asked. What is the reason? In the given system, what will happen? Usually it is expected that this is the input, even though it is reversible, but it is the input port in the two-port network and it is the output. It is expected that we connect some source, either a voltage source or a current source, to input port, and we connect a load to the output port. Load may be a resistor and inductor, resistor and capacitor, any combination of R, L and C, or it can also be another two-port network. So a two-port network has input and output. You may cascade it. So input of the second is output of the first. So effectively for a cascade network again, one is input and one is output. So ultimately you connect a source at the input and a load at the output with multiple stages of cascading. So unless we terminate the network with some load which is not part of the network, unless we terminate the network with some load which is not part of the network, the parameters Y21 and alpha 21 would be zero parameters. Right? These parameters are that way not the exclusive characteristic of the network itself, two-port network itself. Because of why? Because for two-port network as such, those are zero only. But when we terminate the load with a resistance which is separately connected, under that condition, the ratios Y21 and alpha 21 gets defined. Otherwise, those are insignificant. Are you getting me? So we have 2 points here, 2 points here. We may connect some source here and we may connect some load here. Not connecting any load is also what one can say as a no load condition. So voltage can be seen there. Therefore, the ratios V2 upon V1, that is Z21, and another ratio, that is which one? V2 upon, sorry, transfer ratio G21, that is V2 upon V1, and impedance, transfer impedance V2 upon I1 are defined. These are defined independently for no load condition also. Whereas the other two are zero for no load condition. But the moment at which we terminate the network, so once we connect a load to the network, we can say as RL. Then when we connect RL, all the parameters also get modified. All the parameters also get modified. Means G21 and Z21 which you have calculated for the network itself under no load condition will not remain same. And in this case now, you can compute all parameters. G21, Z21, this RL I am specifically giving 1 ohm. This RL I am specifically giving 1 ohm for simplicity right now. Then you have to compute G21, Z21, in addition Y21 and alpha 21. Y11 I am not asking to compute. Why? Because this is 1 upon Z1. So you compute these 5 parameters again for the same network. It's not repetition, it's a different set of problems now. Compute. For passive network, this is a very simple computation, no much significance is to be attached. But for active networks, thing change drastically. Five ohms, 1, 2, for this network